Everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, and bringing you once again the next in our series of what to look for in the night sky. This time for the week of February 14th, 2022, halfway through the month of February. So we'll start off briefly. This part of the board beneath the rectangle that we've drawn right there is not associated with the rest of the board. The moon. We've been talking about where the moon is and the planets and so on for many weeks in a row right now. I hope you had the chance last week to watch the moon as it went through Taurus, very near the Hyades and the Pleiades. Made a great view. I was able to get pictures with my cell phone. It's just such a fine scene that we had. This next week, on the evening of the 15th into the morning of the 16th, for those of us in North America here, the moon will be sort of in the sickle of Leo. So the head of Leo looks like a sickle like that, and the tail looks like a triangle. And the moon will be here. By the next night, it will have moved down next to the bright star Regulus. And so if you're out there and you want to check this out in the evening of the 15th to the 16th and the 16th to the 17th, the moon's going to be basically full at this point. It's very close to full. Tracking through Leo, something worth checking out. Spending just a few minutes to watch the moon, especially near the bright star Regulus, right here, I think. Other than that, we're going to talk a little bit about some things that maybe aren't as easy to see in the evening sky. So this is, if you have a small telescope, this will work pretty well for you. There's my stylized version of Orion. Orion's up when it gets dark right now. All of this is up when it gets dark and moving towards setting. So if you're watching later at night, you might have a little bit harder time seeing some of this, especially the stuff that's up in this part of the sky. So here's Orion, and we got Betelgeuse and Rigel down here, and above Orion is Taurus the bull. There's the Hyades with the bright orange Aldebaran, the eye of the bull there. That is that V shape, a really nice V shape that you can see. And here's the Pleiades, open star cluster. Just above there, this is where the moon passed through last week. Now, if we extend the V of the Hyades on out, and we've done this in other weeks, we get to Zeta Tauri and Elnath, Beta Tauri, up this direction. So these are interesting stars in and of their own right, but we're kind of interested right now in the Crab Nebula that sits just 1 degree, just 1 finger width above and a little bit to the west of Zeta Tauri. So if you can track this out here, you can find the Crab Nebula. The Crab Nebula, the first in Messier's famous list of objects that are interesting to look at in the night sky. The Crab Nebula is the remnant of a supernova explosion that occurred in the year 1054. This was a very bright supernova, would have been very bright in the night sky, bright enough to see in the twilight of morning and the evening as well. There aren't a lot of records worldwide of astronomers having observed this. Astronomers in China and Japan, we have records of observations there. Some records other places that maybe refer to it and maybe don't, where it's a little bit hard to tell. But this supernova explosion occurred in the year 1054, and what's left is the gas, the remnant of that star that was destroyed in the supernova explosion. So what happens in a supernova explosion? A heavy star probably needs to be 8 times heavier than the sun, or maybe a little heavier than that. It's a real tricky thing, right? Because heavy stars tend to lose mass at the end of their lives. They have strong stellar winds. They're blowing mass away, trying to become lower mass stars all the time. And they're interesting, like Wolf-Rayet stars out there. They're interesting stars where you see the nebula of gas around the star as it's shedding material at the end of its life. So it's no guarantee that if a star starts out heavy enough to become a supernova, it will become a supernova. But it takes a pretty heavy star. Pretty heavy stars, stars that are, say, 10 times the mass of the sun, don't live very long. They burn through their hydrogen fuel very quickly, and they go through all the stages of stellar evolution very quickly, so they're not around very long, and they're harder to make. It's much, much easier to make a star half the mass of the sun, or 3/4 the mass of the sun, or the mass of the sun, than it is to make a 10 solar mass star. So what that means is there just aren't many of them. They're hard to make. They don't stick around very long. There aren't very many of them in the night sky. And so those that are there have the possibility of becoming supernova explosions. What happens is you fuse all the hydrogen into helium in your core, and then you start fusing hydrogen into helium in a shell around that core. That's what we would call a red giant star. At some point, that star will get hot enough. The stuff precipitates inward. The helium falls inward, and as it falls inward, gravitational potential energy gets converted to some of it gets converted to thermal energy to high, and the temperature goes up. And when the temperature in the core gets to be high enough, you can start fusing helium in that core into carbon. And then all of that helium in the core, very quickly, all that helium in the core becomes carbon, and you start to make, you start to fuse in shells that get successively further and further and further out through the star. And then the heavier stuff, the heavier material that you're making in nuclear fusion is falling toward the center, heating up the core. Now, in normal material, when you heat it up, the pressure goes up. And the ideal gas law, for example, there are other kinds of pressure, but the ideal gas law tells you that as the temperature goes up, the pressure goes up, and that causes it to expand. And if stuff falling inward heats up, stuff expanding outward cools down. And so that relieves the pressure. That takes the pressure off the core just a little bit. But the cores of these we're now asymptotic giant branch stars. We're now not exactly red giant branch stars anymore. We're on what's called the asymptotic giant branch. And these stars that are fusing hydrogen to helium out in their cores, they're supported in the core by something called degeneracy pressure. Electron degeneracy pressure has to do with quantum wave functions overlapping and how many particles can fit in a quantum state. But that's a video for another time. Anyway, it turns out that that's a temperature independent pressure. So as it gets hotter and hotter and hotter, the pressure doesn't go up and it doesn't expand. In fact, it's going to contract a little bit as it gets heavier. And so the temperature goes up and up and up and up and up. At some point, you can photodisintegrate that. You get light in there, photons, gamma rays, that are energetic enough to blow apart the core of that star, to dissociate it back into protons and neutrons, and the core then collapses. When the core collapses, everything falls in, and a neutron star gets formed. When neutron degeneracy sets in, and you get a core rebound, and all that material hits the neutron core and bounces back out, and it rips out through the star, just destroys the outer layers of the star, leaving a neutron star behind in a nebula, like the Crab Nebula. So that's what happened in the year 1054. Boom, boom. And so, again, you need a heavy star to do that. Lighter stars, like the sun, will become planetary nebula. As I tell the students all the time in astronomy class, as Led Zeppelin sang, but there are two paths you can go by, but in the long run, there's time to change the road you're on. Low mass stars can gain mass from a companion, and as we just talked about, high mass stars can shed mass. So it's possible to cross here. There's a completely different kind of supernova that occurs when a white dwarf star accretes material from a companion. A white dwarf is what would be left over after a planetary nebula. Anyway, most of the stars, vast majority of the stars in the sky will become planetary nebula, and only a few will become supernovae like this. Here's a chance for you to see a supernova remnant. It's a low contrast item. It's not glowing brightly against the background sky. What it has going for it is it's only a degree above Zeta Tauri here, and you can, by extending out the Hyades, you can find Zeta Tauri. And if you have a small telescope, scan that region, scan slowly, because of that low contrast, you'll scan right over the top of it and miss it. But it's interesting to see this supernova remnant, famous supernova remnant, one of the best we can see in the sky right here. Give that a try. Move on up to Capella. So you go from Betelgeuse to the Crab Nebula to Capella in Auriga up here. And then off to the west of Auriga, we have the Perseus. And Perseus is that J with strands of legs coming down here. The J points up at the double cluster, 2 open star clusters. Beautiful, beautiful. If you got a pair of binoculars, great. If you don't have a pair of binoculars, you can see these without any optical aid. So just follow the J of Perseus up here. Check out the double cluster and enjoy it. This whole region of the sky would be better observed in the evening in fall. But we wanted to continue up this direction because we got the Great Square of Pegasus on over this direction with Andromeda. the V of stars coming off the great square of Pegasus. And above, as you walk out this V, I think we called it a cornucopia when we did this back in November. We had the Andromeda Galaxy boom, boom up above here when you go a little step out. If you keep going on out, follow this upper strand out this direction. And just when you get to the end of the upper strand of stars in this V of Andromeda coming off the great square of Pegasus, you're going to bump into M76, another Messier object. And we like that. It's called the Little Dumbbell Nebula. And we like that because that's a planetary nebula. So if you have the opportunity to see the Crab Nebula and the planetary and the Little Dumbbell Nebula, a supernova remnant and a planetary nebula in the same night, go out and do it. It's great. This is pretty small. Almost all planetary nebula, are small and hard to see because they're small. So you probably do need a telescope. Even if you can see this with a pair of binoculars, you're going to have a hard time telling it's not a star when you look at it with your binoculars. So it's pretty small and it's pretty faint. So it's not one of the easiest objects to see, but you can track this V, this part of the V of Andromeda up to it and see if you can find it. If you can't find it, that's okay. You've got a lot of other interesting things to look at. Enjoy this part of the sky where you've got Orion, into Taurus, into Auriga, into Perseus, into Andromeda, and see if you can find these objects out there, and definitely take a look at the double cluster up there. Two big, bright, open star clusters. Lots and lots and lots of stars to enjoy. So that's what we got for you this week. Check out the moon as it's full, heading through Leo, and then go out and enjoy the Orion all the way up to Andromeda region of the sky, and see if you can find the Crab Nebula and the Little Dumbbell Nebula, and think about the end states of stars. Think about how low-mass stars tend to want to become planetary nebula, and high-mass stars can become supernovae. And we'll have more to talk about next week. I hope you have clear skies and enjoy the sky. Enjoy the observing, everybody. Have a good week.